Hey everyone, this is Mrs. Slauson, and we are going to be on page 16 in our spiral. We're going to cover solving today with absolute value. So if you don't have your spiral out yet, pause this video so you can get to page 16, and then we'll start. So in order to understand solving, we're going to put a picture to it to help you guys understand some of the stuff that we're going to be doing. So we are going to be graphing this equation right here in two parts. The first part that we're going to graph is just going to be this absolute value of x, which we graphed last class. And since there's no a, h, and k to it, we are just going to graph the basic parent function. So the points we're going to use are the points that fit on this graph. So if x is -4, if x is -3, -2, -1, 0, and then I'm just going to get the positive sides. And if you remember, absolute value is how far a number is from x. So what's its distance? And distance isn't positive or negative, it just shows that you've actually gone some spaces. So if you take the absolute value of -4, you get 4. So it's this point. And -3 is 3. And -2 is 2. So I'm just going to work my way through some of these and graph them. And then when I get to the positive values, well, I just still get 1, 2, 3, and 4. So we get this V shape that is known as absolute value. And then as we talked about last class, adding A, H, and K will have this graph start to look a little different. But in the end, it's going to look like a V. So let's take a look at the other side now. So when we graph this side, this is just y equals 3. So this is a y flies by at 3, and the other one was y equals the absolute value of x. So if I do y flies by at 3, let's get a different color here, I'm looking to see where these two graphs connect. So one place they connect is at 3, 3, and the other place they connect is at -3, 3. And we're trying to figure out, what do they have in common? And that is this. So their answer, whether I take the absolute value of -3, I get 3, or if I take the absolute value of 3, I get 3. All right, so with that, we're going to start solving, and we're going to bring in this idea that as long as I take the absolute value of a number, whether it's negative or positive, I'll always end up with the positive thing. All right, so let's just go through this. This should be review. You should have seen this somewhere in middle school. You just haven't really seen it since then. Maybe a little bit freshman year in Algebra 1, but not so much. So what I'm going to be doing is I'm going to be solving for x. I just need to get x alone, but this time x is going to be in these bars. So what I'm going to have to do is not isolate just the x, but I'm going to isolate the bars so that I get something that's just only the absolute value bars equaling something on the other side. So working through this one, we're just going to work backwards. So first I'm going to add 7. And then I'm going to divide by 3. And when I'm done, I have 6. So if you think about what we did up here, is that there are going to be two numbers, -3 and 3, that if I take the absolute value of them, I got a +3. So the same thing is happening here. I can take the absolute value of two different numbers to get 6. So one of those can be 6. So if I take the absolute value of 6, I get 6. But then there's always the option that I can take the absolute value of, let me fix this, of -6, because the absolute of -6 is also 6. So what you're going to see is, because we're having some type of V shape on the left side of the equal sign and some y flies by on the other side of the equal sign, this V is going to connect your y flies by line most likely 2 times. It could also be once, and we'll explore some of those. And it's also possible that the V and the line will never meet as well. So let's take a look at the others. All right, let's go to the next one. So what I have to do is isolate those bars. So first I'm going to add 6. And then to get rid of the fraction, I'm going to multiply by its reciprocal. So I'm going to multiply this by 3 halves, because the 3's will cancel out and the 2's will cancel out, which means I'm going to multiply the other side by 3 halves. And just to remind you, multiplying by fractions, very simple. You just multiply across for 24. You multiply across for 2. So the right side becomes 12. And the left side is now just the absolute value bars. So again, what could happen is I could take the absolute value of 12 in the bars to get to my 12, but I could also take the absolute value of negative 12 to get the 12 that's on the other side of the absolute value bars. So I'm going to turn this into 2 problems. I can add something with 3 to get 12, and then when I take the absolute value of 12, I'll get this 12. But I could also add something to 3 and get negative 12, because then when I take the absolute value of this negative 12, I'll get this 12. So in the first situation, I'm going to subtract 3, and I get 9. And then in the other situation, when I subtract 3, I'm going to get negative 15. All right, so we're getting 2 answers. All right, let's go to the next one. So in this case, isolating the bars, I'm going to add 1 first. And then I'm going to divide by negative 2. And then I'm going to stop. And this one is actually going to have no solution, because when I do take the absolute value of something and I'm explaining how far away it is from 0, a distance is a positive value. So I can't take the absolute value of something and get a negative number. That's not going to happen. So this one is a no solution, because you can't take the absolute value of something and get negative 4. I could get 4, but not negative 4. So just real quick, what this would look like as a graph, I'm going to erase this stuff up here, is I would have a y flies by line at negative 4. And then I have my v, which is somewhere below this line, and the 2 shapes would never meet. And if I had a better graph, I would remind you of how we graphed this problem from last section. This is a y flies by line, and they would never meet. So that's why there's no solution. All right, just some pieces for vocab that's going to pop up the year. Sometimes I'm just going to say find the zeros. And finding the 0 of a function is we're trying to figure out what x values make it so that the whole function is worth 0. So basically, if it says find the zeros, I'm going to take whatever my problem is and set it equal to 0 and solve for x. So when it says find the zeros, and I need to find the zeros of this, I'm going to set the problem equal to 0 and then just solve for x. So same idea, I'm going to solve for x. To avoid some messiness with negative numbers and stuff, I'm going to add the 3/5 x to the other side. And now to get rid of the fraction, we're going to multiply by the reciprocal. So they're dividing by 5, we're going to multiply by 5. Cancels out. And where they're multiplying by 3, we're going to divide by 3. So those cancel out. So then I'm going to do the same thing over here. And not be afraid of fractions, because I can just multiply across for 45 over 3, and when I'm done, 45 divided by 3 is 15. All right, in the next one, again, it says find the zeros, so I'm just going to take the problem and set it equal to 0. So the first thing I'm going to do is subtract the 2 over. And then I have this negative here, which is actually like a negative 1 hanging out. So I'm going to divide by negative 1 now. And then I have 2. So again, I've got some v shape. That's the x plus 3. It's crossing where y flies by at 2. And I'm just trying to figure out those 2 different answers where that's happening. So I have to realize that I could take the absolute value of -2 to get to 2. So something with 3 could equal -2. Or I could take the absolute value of a regular 2. So some number plus 3 could give me a regular 2, and then take the absolute value of that to get the 2 that's here. So in my first situation, I'm going to subtract 3. So I get -5. And in the other situation, when I subtract 3, I'm going to get -1. So that means these two are meeting at -1 as far as the x value goes, and -5 as far as the x value goes. All right, my suggestion is you stop here, you move into the practice, and you start working on the problems that are involving solving absolute values with an equal sign. Once you do a few of those, why don't you come back onto the notes, hit play, and then we'll continue on. All right, now let's move into inequalities. So here, suppose we want to solve this inequality. So luckily, they've already graphed the absolute value like we did on the other one. That's why all those points are popping in. And then this says we want to solve the inequality where I want to focus on the part of the absolute value graph that is less than or below this y flies by at 3. So let's put the y flies by at 3. And then again, this is saying I want to be not below. My mistake. I wasn't looking at that carefully. Greater than. So greater than or above this y flies by at 3, which means I want from here to here and then here to here. And if you think back to the increase and decrease, we've got two areas of where this graph worked. So if I were to mark my important points, -infinity, infinity, 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 and then I've got this is an important point, -3, 3, and then 3, 3. We're solving for x in this situation. So again, I'm going to focus on where are the x's going to work. So they're going to start at -infinity to -3. And then they're going to pick back up at 3 and go to where x is infinity. And then I just have to decide, do I want to include my answers or not? And since in the original problem, it is not underlined, I will put parentheses around there. Okay, and you're going to hear me later reference this as the alligator. So let's take a look here. So in this situation, if you kind of think about what this would look like, visually, we've got 2x minus 5, so that might look like something like that. And then we've got y flies by at 3, so maybe that looks like that. And this says you want the part of the line that's greater than or above the 3. We're going to solve these visually. So wherever these two happen to meet, then I would want the part that's above it. So let's see where this point is, because I already know that this is infinity, infinity. So solving 2x minus 5 is greater than 3. I'm just going to solve like there was an equal sign. So I'm going to add the 5. And then I'm going to divide by 2. And so where these are meeting is where x is 4. And so if we're going to write our answers, let's see, I don't think it says. Okay, we want to write this as where x is bigger than 4. So in interval notation, that would be 4 to infinity. This is not underlined, so we'll do parentheses. If you want to write it as an inequality sign, it's just where all the x's are greater than 4. But this is our goal to use in Algebra 2. All right, let's take a look at the other two. So the first situation is I have a regular v. It is not flipped. And then I've got this y flies by at 7. And we're going to see if we can figure out where these two meet. So now we're just going to solve. And just like before on the equal part, we're going to isolate these bars. So that means I'm going to subtract 1 first. Then I'm going to divide by 2. And then if you think about there really just being an equal sign in there, again, just kind of holding off on the inequality, I can take the absolute value of -3 to get to this 3, and I can take the absolute value of 3 to also get to this 3. So that's what I'm going to do. I'm going to take x minus 3 and have it equal to -3, and x minus 3 equal to +3. Notice that nothing in the bar changes. It's what's outside of the bar that changes. So in the first problem, I'm going to add 3 right here, and that gives me 0. And then I'm going to add 3 in the other one, and I get 6. So these two shapes are meeting where x is 0 and where x is 6. So what we want to see is what part of the v do we want. So I'm going to come back up here, and this says we want the part of the absolute value that is below our y flies by at 7. So again, this is our y flies by at 7, and this is our v. And this is the part that we want from here all the way to here. And if you think about what we did in our first two sections, this would be anywhere from x being 0 to x being 6. And because this is underlined, I should include those two values. All right, let's try one more. Let's try the one at the end. All right, so let's just solve this first, then we can look at it visually. All right, so isolating the bars do not change. It will stay x plus 1. So I'm going to subtract 3 first. And that gives me 1. And then it's like there's a -1 hanging out in front. So I'm going to divide by -1. So we are dividing by a negative. So when we divide by a negative or multiply by a negative, this inequality sign is going to change directions. And now I have -1 over here. And before we move on, whenever I'm stuck with just a negative, when I'm stuck with a negative over here, not a positive like we had here, I really need to slow down, because if you remember, if we take the absolute value of something, it's got to be a positive number. So no matter what I get here, I'm going to get some type of positive number. And this is saying that that positive number has to be smaller or less than -1. And that can't happen. So what's really happening here is on the left side, we have some upside down v. I know it's upside down because of that negative, it flipped. And then way above it, we have 4. And these two are never meeting. So in this particular solution, the fact that I ended up with a -1 on the outside really caused me to pause. And when I think about it, I'm not going to have an answer because positive numbers are not less than -1. So this one's going to have no solution. All right, let's just practice a little bit more. Okay, so again, as we go through these, I really want you to think visually about what's happening to the graph so you can figure out what part of the graph you want. So in the first one, this is just a line, right? 3x minus 7. Let's pull a graph. So something like this. And we're trying to see, we want the part of this line. Let's do a different color. And then I'm going to have my y flies by line at 0. So that's this part. Here's the 0. All right, let's just solve as we normally would. So the first thing I'm going to do is add the 7. And then I'm going to divide by 3. And you are welcome to leave this as a fraction. It might help us a little more sometimes if it's a decimal. So that's going to be 2 1/3. Or that's a mixed number, sorry. Or as the decimal. So right now where my green line, the y flies by at 0, and my crazy color line meet is right here. And that point happens to be 2.333. And so this is saying you want the part of the line that is greater than or above your y flies by line. So that's going to put me here. And if this is my x coordinate is 2.33, then this is infinity, infinity. And I would just write my answers as 2.33 to infinity. And since this one is underlined, I'll put a bracket. All right, let's try the next one. I assume on this one, I don't think the directions just got left off, that we're solving it, find the zero. So I'm going to set it equal to 0. I'm going to put it on the other side though. All right, this is an equal sign problem. So here we go, just a little bit more. So I'm going to subtract the 2. That's going to give me -2. And now to get rid of the fraction, I'm going to multiply by the reciprocal. So they're dividing by 2. I'm going to multiply by 2. Cancels out. And when they're multiplying by -1, I'm going to divide by -1. So those cancel out, which means I'm just going to come to the other side and multiply by -2 as well. So my left side is x minus 3. My right side is now +4, which is good. We want a positive there. And so I just have to remind myself that I can take the absolute value of 4 to get to 4, or I can take the absolute value of -4 to get to 4. So I'm going to have x minus 3 with 4. I'll have x minus 3 with -4. Again, just pointed out this, whoops, that is not what I meant to do. What's in the bars never changes. Notice it's always staying x minus 3. So I'm going to add 3 for one problem, get 7. I'm going to add 3 for another problem, and I get -1. So if we think about visually how this works, this side is an upside down V. The other side is y flies by at 0, and they are meeting at -1 and at 7. All right, let's go to this problem. So what do you do when you've got two inequalities? Well, all they're doing is, this is just two problems. So one is this, and here's the other one. Okay, I'll show you visually what's going on in just a moment, but I'm just going to solve for x. So my first problem, I'm going to subtract 1, and then I'm going to divide by 2. And then I always prefer x to be on the left side. It just helps me with my thinking. So all of my answers will be greater than -2. And then on this one, I'll subtract 1. And then I'll divide by 2. And so here all of my answers are smaller than or equal to 3. So if we put this kind of like on a visual, we've got our line, right? And then, because this is y equals some type of line, and then we have a y flies by line at -3. We have a y flies by line at 7. And I want to take the part that is essentially, if you think about it, so this one's meeting at -2 because it's further over. This one is meeting at 3. And I want to go bigger than -2, but smaller than 3. So my answer is somewhere in between here, -2 and 3. So I'm going to write it like this. With the -2, I will leave it open, and with the 3, I will close it. All right, last problem, and then you guys can go and finish up your notes. So a plane is flying at a cruising altitude of 30,000 feet. It begins a descent at a rate of 1,500 feet per minute. So first we're going to write a function that models the altitude of the plane after descending for t minutes. So our function is going to be what's the altitude based on the time. And this is going to be linear because as a plane flies, when it starts to land, it's going to kind of go more like this. Okay, so this is the part that we're figuring out. So in the beginning, which is right here, the plane is at 30,000 feet. So that's our y-intercept. And then it's going to descend, so going down 1,500 feet every minute. And they want us to use t for time. All right, so here's our equation. First time we got an input, so if t is 4, and then I would use my calculator and type this in. You can just type in the whole thing. You can do this in pieces. And if you take 1,500, so I'm going to do this in pieces. We're going to get 30,000, take away 6,000, and when we're done, we get 24,000. And then you have to explain the meaning of this value in context. So after 4 seconds, the altitude That's is 24,000 feet. All right, so now they want to know at what time or times is the altitude of the plane 1,900 feet. So that's the altitude. Remember, this is the altitude. I am spelling it correctly here. And then the t is our time. So when we take this 1,900, I'll put it over here, or sorry, 19,000, and then I'll just work to get my t alone. So first we can subtract our 30,000 over. That gives us negative 21,000. And then we can take and divide that negative 21,000 by 1,500. And when I do that, I'll get 14. So it's going to take 14 minutes for that to happen. All right, and for what values of t is the altitude of the plane between 15,000 and 8,000? So if this whole equation represents the altitude, then between is putting it like this. And in this situation, instead of breaking it into two problems, I'm going to show you with one problem. So essentially, putting these lines here, I'm going to get this t over here in this part alone. So first I'm going to subtract 30,000, gone, but then I'm going to subtract 30,000 over here. So that gives me negative 1,500,000, sorry. And then I'm going to subtract 30,000 over here. So that leaves me with negative 12,000. And now I'm going to divide by the negative 1,500. So that cancels out. There's t. I'm going to divide by the negative 1,500 here. And then when you take your 15,000 and you divide it by your 1,500, both being negative, you get 10. And then I'm going to divide over here as well. So I'll take negative 12,000 and I'm going to divide it by negative 1,500. I have too many zeros there. Let me cross one of those out. And I get 8. But we have to remember that I just divided by a negative here. So that's going to switch my signs. And the best way to write this is with t and the two betweens, and then 8 and 10. So between 8 and 10 seconds would be our final answer. So at this point, go finish your practice. That's all you have to do today. You don't know what I'm going to pick up. Maybe I'll take a look at your notes. Maybe I'll picking up your assignment, but I will pick up something the next time we are together. When you're done, I did leave some coloring sheets. Otherwise, you can work on something from another class. You can read, but not on our phones.